climber has a fall but is caught by a 35-meter long, 0.75 centimeter thick nylon rope. If the maximum stretch of the rope as it catches the climber's fall is 160 centimeters, what is the maximum force of the rope applied to the climber? And it turns out this question kind of builds on the last one, so we can actually use a result that we just got. In the last question, I had calculate the equivalent spring constant for a rope with the same characteristics as what's described here, including the Young's modulus of nylon that this question doesn't provide, but we should remember is 3 times 10 to the 9 pascals, or at least we should remember for since one question. I'm not saying memorize that for this class, but anyways, I would either provide that or let you look it up. Anyway, we have that though, and we have this number at 4 significant digits. That was before we rounded it for the question, the last question that is. Recognizing this is a spring constant though, we could maybe approach this question since it's asking what is the maximum force, and F is equal to, in this situation, maybe using that delta L, since this is kind of a Young's modulus situation, that's the customary notation for that, is use this version of Hooke's law and then combine that with the spring constant that we are given. So in that sense, this question is actually maybe very straightforward, because all we have to do is multiply the spring constant in newtons per meter times the delta L representing the stretch of the rope, and it says maximum stretch, which is naturally where the maximum force is going to be, so that's what we're going to multiply by. I'm going to put that in as meters, though, 1.6 meters, and then put that into my calculator in that way, and it gives an answer of like 6,059.2 newtons, although maybe I'd like to round that off a little. I think 2 sig figs is good enough here. Oh, how do we do that here, right? One possibility, that at least I remember being taught by a chemist, I think it was to do something like this, although maybe better way would be to use scientific notation. 6.1 times 10 to the 3 newtons. Then it's very, very clear. And again, I'm not super picky about that, but it is good to kind of know that that's out there. So there it is, 6.1 times 10 to the 3. I put the observation there. Perhaps a longer rope would have been more comfortable. That seems like maybe somewhat large force for a person to have to experience. You know, another option would have been a rope that is not quite as thick. I think this rope might be a bit on the thick side for climbing. Maybe another material would be a good idea as well. I'm not sure. I'm not a climber, so I don't really know the details beyond that.